All right, let's begin. Welcome everybody. Today we're presenting FARO As-Built for AutoCAD. So it'll be myself, Dino Kapich, and Floyd Modena. What we want to show you guys before we start is how we actually introduce 3D point clouds within our As-Built products for AutoCAD. So just so you guys know who's part of the Modena FARO team, we have Nalene Foster, who's our FARO service and sales personnel. We have Peter Buerter, who is our 3D laser scanning technician. Floyd Modena is my partner here who's presenting with me. He's one of our applications engineer. And of course, myself, Dino Kapich, as well, another applications engineer who deals with the AutoCAD and the Revit suites. Just a brief agenda for today. Floyd will go over a brief overview in terms of how we go from scanning to 3D point clouds. You'll be doing an introduction to the As-Built product and how it links into AutoCAD. I will then be discussing scan navigation features, its benefits in AutoCAD, as well as a demo on how we utilize this item. I'll be going through the basic tool sets to help you model key components in your point cloud projects. Floyd will then go through the basic analysis process that is introduced in AutoCAD As-Built, as well as the automatic pipe and structural extractions. And then finally, we will have our Q&A session where you have the freedom to question Floyd and myself after our presentation. So let's jump right into it. Floyd?
Thank you very much, Gino, for such a great introduction. And thank you all once again for joining us in today's exciting webinar. I hope you'll find it very insightful. Well, under a brief overview, it is critical that we understand how the laser scanner works. Well, I'm sure many of you know and some of you don't. Well, for those that don't, basically a 3D laser scanner sends out 1 million points a second, that when a point reaches an object, the position of the object is recorded together with its RGB value for a more clear and realistic display of the point cloud information. After the field work is done or complete, the individual scans are collectively registered to create the point cloud of the building, structure, or the plant that needs to be modeled. From there, we use this point cloud to extract 3D CAD models in AutoCAD or similar CAD products combined with an intelligent extraction process. Now, this is where AsBuild for AutoCAD comes in with its systematic and enhanced tool sets. As we know, all buildings or renovation projects require accurate and up-to-date plans of the existing building or reality. The big question is, are you tired of working for hours or even days working on a 3D model? Do you have an intelligent 3D model of the existing plant or structure or feature or MEP component? Well, your answer is AsBuild for AutoCAD. Well, FARO As-Built software solutions are innovative and profitable tools for complete and efficient conversion of reality captured data into parametric CAD and BIM models. AsBuilt delivers a very powerful industry-specific functionality for easy, precise, seamless, and efficient evaluation. Because FARO partnered with Autodesk, this is what we can do. AsBuilt for AutoCAD guarantees the most direct workflow from any captured related data, dramatically reducing the time for model extraction, minimizing the amount of construction rework, controlling project cost, and increasing quality. This confirms that AsBuilt for AutoCAD provides a more efficient workflow from any captured related data, such as 3D laser scans and functional CAD and BIM models as stated. The analysis tools available serve for quality control of the model object, as well as for determination and visualization of deformation. Plant components, piping systems, and structures can be automatically detected and recorded along with their parameters. Exact connection points can be determined without modeling. The integrated data capturing feature is useful for facility management and real estate management, as well as for component lists from piping systems or for damage mapping of facades of historical buildings. The photogrammetry tools are available in addition to the inventory and documentation of historical and building research. It also has an interface for total stations. Just imagine an interface for total station that enables the staking out of points moved directly from design into reality. When measuring using your total station, basically, the total station becomes the 3D mouse, which directly transfers data into AutoCAD. How great is that? And looking at the current market, AsBuild for AutoCAD provides a more optimized, easy to use, and efficient solution. It reduces the time we usually spend on modeling from a point cloud. It increases accuracy, as well as improves the consistency of our deliverables. Additionally, it works with any AutoCAD-based software such as Plan 3D, AutoCAD MEP, Advanced Tool, and many more. So if you prefer working on Plan 3D, for instance, this will add to your advantage. Dino, let us take this to the next level. Please take us through the scan navigation tools and the benefits of using that feature.
Thank you, Floyd. So in terms of the scan navigation, with this command, you create the markers for the scanning position, or you get to see the markers of the original scanning position. So there are benefits of the scan navigation feature. One of the main benefits is you control how to navigate your scans in AutoCAD. Imagine the smooth, easy to use 3D navigation now within AutoCAD, and that is with the point cloud elements. Another benefit is we have the ability to stand at the exact location of where the scan data was taken. So no matter if you haven't met the technician on site, or if you've never been on site, for a matter of fact, you can still stand in that position on your AutoCAD project. Another one is we have scan navigation bubbles that are linked to your layer properties. So these elements are now viewable within AutoCAD as an orange bubble, as you see on the picture. And the fact that we can control them in our AutoCAD layer properties just leverages a better modeling experience. Scan navigation can be viewed in first person or third person. So the idea is we can get an overall realistic view of our item, or we can go into that specific position and see it with our own eyes in a third person view. Of course, you can create your own scan navigation bubbles, and this brings a whole lot of benefits. So let's take a look at a demonstration on how this is actually done within AutoCAD As-Built features. So remember, before we go into this, we optimize the way you view your scan data.
In AutoCAD As-Built, we can use the Scan Nav feature to select, drop down, and create different points within our model, placing all labels around the object, giving an almost 360-degree view. Select all the labels that you require, go back to your Scan Nav, select, and then pinpoint a specific location within your project. Once location has been selected, all scan navigation labels will look at that specific direction. Going into the scan, you can see exactly where the scan is looking up to. And of course, you can adjust your transparency for this element. Going into a real-world view allows you to adjust in different perspectives. And again, you are able to jump from one point to another to get a highly viewed item within your AutoCAD project.
Other items are your basic tools, and think of this more as a quick start. There are 3 basic tool sets to work with. All can be found in the As-Built tab for AutoCAD when you install. These 3 tool sets consist of the section tools, the fitting tools, and of course, the digitizing tools. When we look at the section tools, these tool sets are designed to help us crop, clean, isolate any sets of points within our AutoCAD project, as well as create multiple views from the section in our tool sets to go back and rework with. When it comes to the fitting tools specifically, we have the ability to have an accurate tracing of points in the AutoCAD project. And that is with the fitting tools within As-Built as well as in AutoCAD. And of course, we can snap to the point cloud elements because AutoCAD has these abilities with snapping features. So every point that you select within your AutoCAD project can be snapped to, whether you're zooming in or out. And of course, these elements are available in your AsBuilt tab functionality. When we go through the digitizing tools, we adapt AutoCAD's UCS to your point cloud for a better modeling experience. And of course, we create multiple planes from the point cloud to perfect alignment in our 3D models. And once more, these features are in the tab for you to quickly go select and utilize within your project. So let's take a look at some of these basic tool sets in combination with each other when we are modeling off a point cloud within our AutoCAD project.
Within your AutoCAD project, AsBuilt allows you to use these three basic tool functionalities in combination with each other. This makes modeling of point clouds a lot more streamlined in this package. So let's take a look at how we can isolate key components. I want to take a look at this particular area here within my model that I circle. So what I tend to do is I go to a view where it's easy to section off within the model. And again, with the AsBuild tab that is installed with the AutoCAD package, I can go define rectangular objects in my point cloud, snipping out what I don't require. I don't usually tend to work with objects of scan color because I need to see different faces. And again, AsBuilt within AutoCAD allows you to highlight specific surface faces within your scan, regardless if it's top view, bottom view, or left-hand view. And again, with these elements, we can take it, duplicate these views, rename them, for example, and then, of course, isolate them for next time. From here, I want to define even more outcomes. So again, with my AsBuild tool, I can slice my model between the X and Y plane and use even my plinths as base points. Right there, I now have a general floor plan to work with within my AutoCAD project. And again, if I navigate to a floor plan view, I've got something very defined within my model to work with. So right here, I can already see the map outs of plinths, columns, and beams that are being placed within my model. And of course, you can always slice further up and further down to get rid of unwanted point cloud elements. You can utilize many different combinations of features within AutoCAD. Remember, you still have access to your basic AutoCAD tools. So the idea of modeling now within that space becomes a lot simpler. As you can see, place down the lines that you require, go into a 3D extrusion, place again, and of course you have your model in place. Of course, if you change your perspective from wireframe to conceptual, you can get a more in-depth analysis of the 3D geometry you are creating. And once more, AsBuilt allows you to select them specifically, and AutoCAD allows you to change the height values for all objects that you have placed and all 3Ds that you've created until you've gotten something near perfect to what is displayed on the point cloud. And again, if you now need to model back and forth between separate views, you can go select on those views.
Now let's step into the basic analysis. Well, the basic analysis tools serve for quality control of the model object as well as for determination and visualization of deformation. Well, via an ongoing 3D scanning program during a construction process, to be precise, documents are collected and the 3D model can effortlessly be overlaid on the concept model to highlight where construction tolerances are not being met. So what are the benefits of AsBuild analysis? Well, now you can actually perform a class detection directly with the point cloud and the model without having to move to external softwares. And then you can also now perform an accurate cylindrical shape analysis with additional data extraction directly into AutoCAD. You can now perform an accurate cone shape analysis, then also generating Excel spreadsheet. You can also create plane surface analysis. This one you can also use it on floor plans if you want to actually check the deformation of the floor to see if the floor is straight or skew. So this feature actually works very well. So now let us look how these basic analysis tools actually help. Now let us look at this great efficient quality control tool, which is found within AsBuild for AutoCAD, which is the AsBuild analysis tool. Under AsBuild analysis tool, I'm only going to be touching on the cylindrical analysis, which you can use for your piping and tanks and anything that contains or has a shape or a cylindrical shape. So in this case, I'm just going to go straight to AsBuild. As you can see, there's no model yet. I'm just going to go to cylinder and then fit cylinder using visible points. Give the algorithm time to find the model. Yes, it was able to actually determine the right fit for this point cloud. Then I'm going to go back to AsBuild analysis, select cylinder, go select my cylinder and select any point as a system point. Then go to settings. I'm just going to keep these sets according to default settings. I'm also going to keep these according to default settings and keep these results according to default settings. I'm just going to rename this to webinar ANSYS. Great. Then I'm just going to go to start. Give this a few seconds to determine the upper bound, which is the maximum deviation, and the lower bound, which is the minimum deviation, and also show us the area of deviation within the point cloud and the model itself. Great stuff. Our upper bound is 16 and our lower bound is negative 46. I'm going to keep this where it is, and then I'm just going to force the software to actually rename the point cloud, the catalyzed point cloud, which is the unwrapped version of this point cloud. And then I'm going to say unload existing point cloud, which means it will remove this point cloud and keep the model. Give it a few seconds. As you can see, there's quite a number of analyses that can be performed here: cone, plane, as well as class detection, but I won't be dwelling out much on that. As you can see, the point cloud has been wrapped, and now it shows us the deviation within the model, where the gray area actually symbolizes the area of deviation. Now let me just erase this for now. Then let's go straight to the heat map. Great stuff. Look at it from the top. Then rotate it. Great stuff. As we can see now, we can see a heat map that was done on an unwrapped version of the point cloud, and we can see we can actually obviously factor out that this is the area of high deviation. So now if just say we want to also add a legend, it's simple. We're just going to come to the legend. I'm going to keep this according to default settings and then click anywhere. Then as you can see, this is our legend, where we can see the difference in or the variant between the lower bound and the upper bound and the color of deviation. So yeah, this is the benefits of actually using the AsBuild for AutoCAD analysis feature. Now let us step into this fantastic feature, which is an automatic pipe extraction feature. Well, the benefits of automatic pipe extraction feature is as follows. You can create routes from the point cloud, directly from the point cloud, without having to create a circular sphere, create points, and then extrude and etc. You can just automatically create the pipe. You can also fit accessories, fittings like valves, flanges, and etc. automatically. You can also create isometric. You can also select isometric or imperial specification and data pre-created within the software. You can also export out to CAD and BIM softwares like Plan 3D, Rivet, and etc. Now let us look at the demonstration as to how this software actually works. Now, let us look at the automatic pipe extraction tool found within AsBuild for AutoCAD and see the benefits as well as how it would improve our workflow when working from a point cloud, as well as improve our accuracy and the consistency of our deliverables. So in this case, I'm just going to zoom in, go straight to work the run, find a new run, click 2 points. This algorithm would actually be able to determine the pipe size, and click another point here. give the software an opportunity to actually read this area. As you can see, still searching, it was able to determine a seamless pipe with a 6-inch nominal bore. Now it's trying to read this area to try and find this reducing T. As you saw, it was able to find a reducing T, which is a 6-inch to 3-inch nominal bore, but welded. So I'm just going to accept it. And then in this case, it's still you want to continue from the top of the reducing T. So this, you just go back to straight to other pipe, and then click 2 more points here. Maybe we can end here. Give the software, the algorithm, an opportunity to actually find and analyze. So in this case, it found reducing conical reducer. In this case, we know this is a 6-inch nominal bore seamless pipe. We're just going to click insert and then click OK. And then here we are given an opportunity to actually select by length or by points. In this case, since this is just a demonstration, I'm just going to follow it by points. Click here and then click somewhere here. Then the algorithm was able to actually find that pipe, then give it an opportunity to search and find this elbow. As you can see, the software was able to actually determine the 90 degrees elbow. So I'm just going to click insert. I'm going to end it on this elbow. Let's see if it will be able to also determine this elbow. As you can see, this will really speed up your workflow and the consistency, as well as be as accurate as possible. So I'm just going to accept this. Then I'm just going to click finish pipe run. Then from here, just going to hide the piping. As you can see, everything is sitting where it's supposed to be. Even when I bring back the pipe, you can see this is as accurate as possible. So now a question might be how to actually export this into an intelligent pipe work, so that if, let's say, for example, you want to improve from this pipe, it's easy. I'm just going to hide this, go straight to export. As you can see, this is on Plant 3D. This says erase AsBuild plant objects after report. This is basically an AsBuild plant object. So in this case, I want to erase it so that it replaces it with the Plant 3D objects. And this is also entirely based on the spec that you have within your point cloud. I mean, within your Plant 3D project. So let's wait for it to finish converting. Done. As you can see, it's done converting. Now this is an intelligent plant model. So as you can see, I can start routing a pipe from here, and then done. Mission accomplished.
Thank you for that, Floyd. Keep in mind that when it comes to MEP elements, we can do piping items, but don't feel left out if you're part of the structural discipline. Keep in mind that structural extraction is also possible within the AutoCAD As-Built package. And there are benefits of structural extraction. So one of the main benefits is we can create columns, beams, and more from the point cloud element, so long as it is visible. 2, we have specifications that have been pre-created by FARO for you to use in your AutoCAD project. And of course, if you'd like, you can export to other CAD or BIM software packages, much like we've done within the MEP extraction. So let's take a look at a demonstration video on how we actually go select the point cloud and generate columns and beams and export out. Floyd, take it further.
Now let us dive into the AsBuild for AutoCAD automatic structural member extraction feature. I'm just gonna go straight to fit beam, go to detect type. Let's see, the algorithm must be able to determine or to detect this I-beam on the side. So I'm just gonna click any points here. Just reduce. As you can see, it was able to actually find the perfect fit I-beam. I'm just gonna click accept. Now, if I want to extend my I-beam, I'm just gonna come to extend. Click a point, let me just reduce the transparency. Then click any point somewhere here. So you can see it extended it. And then click another point here. As you can see, the I-beam was fitted very well. Bring back the transparency, as you can see. Now, let us detect or automatically detect this angle iron here. So I'm just gonna click 2 points as well here. Give an algorithm a chance to actually try to detect the point cloud. I mean the points. As you can see, it actually found a bigger version of this angle iron. So it's just a matter of moving this to the right point, recalculate. As you can see now, it managed to recalculate and find the perfect fit. So I'm just going to accept it, as well as go back to extend it to here, and then extend it to here. So this is how the automatic structural member extraction tool will benefit your workflow accuracy, as well as the consistency of your deliverables.
So before we go into our Q&A session, keep in mind that when you are utilizing AsBuild for AutoCAD, it is meant to streamline your workflow quicker and more accurate for a better result in the design package that you are working with, regardless if it is AutoCAD, Plant 3D, and Advanced Steel. So our Q&A session is open. If you guys do have questions for us, you're more than welcome to pose it within the chat box, and we'll do our best then to answer your questions. All right, so as the questions are coming in, Lloyd, in terms of the features that you were utilizing within your AutoCAD project, which one was the simplest one that caught you by surprise?
Basically, the one that got me by surprise is automatic circle extraction and automatic arc extraction. It actually speeds up the process of actually modeling circular objects, like for example tanks, finding pipe locations, finding locations of maybe for example of a juicer. That's the best tool.
That's the best.
Yes, exactly.
So there's actually some really cool tool sets that are coming out for the AsBuild product.
Yes, exactly.
I gotta say, in terms of modeling in AutoCAD in general, just 3D modeling in AutoCAD is quite difficult to do. You need almost like a master's degree in it.
Yes, exactly.
It's a pretty powerful software with a huge learning curve.
Yes.
But I found that when I installed AsBuild for CAD, all of a sudden modeling or tracing over a point cloud was much easier than just generating it from scratch.
Exactly. And the mere fact that you can also now actually do some quality control on your model. For example, let's say you drew, for example, the tank, just going to perform some deformation analysis of the tank. You can actually filter out all the deviation within the tank and the model and remodel it until it's precise as possible.
And that's great, because these elements, again, once modeled in AutoCAD, if you need to ship it out to another consultant, if they're using Advanced Steel, export out, give it to them. If they're using Plant 3D, export out, and they can use it.
Yes.
And for those in Revit, of course, you can link in AutoCAD files to go through even further.
Yes.
I don't think there are any questions coming through this side. So if you guys require more information when it comes to the AsBuild tool, keep in mind that here at Modena, we are your FARO As-Built needs. So if you need to get a hold of a sales consultant, we have Nerleen at modena-ac.co.za. She is more than happy to consult you guys in terms of pricing, products, and of course the laser scanners itself. And then for any type of technical support, you've got the likes of Floyd, Peter, and myself, who are more than happy to answer all questions via email as well. And if you can't get a hold of us via mailer, there is our phone number for our support line. Floyd, you happy with these items?
100%.
All right, guys, it's been an absolute pleasure presenting to you AsBuild for AutoCAD. If you didn't have a question or you couldn't think of one during the presentation, again, these items are recorded and you will find our mail address from there. But from there, guys, thank you so much for your time, and everybody enjoy your day further.